Hello, everyone. Welcome. I'm Miriam. I'm going to be moderating this session. So afterwards, if you have any questions, please just raise your hand and I'll come up running with the microphone. We're here with Vivian Neilley, and she's going to talk about access control to resource data based on consent. So go ahead, Vivian.
Awesome. Thank you. Yeah, so quick who I am. So Vivian Neilley, I'm one of the product managers at Google Cloud. I oversee our HL7 V2, FHIR, and DICOM products. One thing, and a lot of what I'll be talking about today is, as a cloud product manager, a lot of the customers that I have also are utilizing at least 10 other cloud products, if not more than that. And so when I get asked a lot of questions from my customers, they're coming to me with the context of other cloud products or other database products. And so one of the main security controls that most databases have that is kind of unique to FHIR is row-level security. So often I get asked, how do you do row-level security in FHIR? Well, it's not quite a thing in FHIR, and it's not quite a thing when the way that FHIR is stored is really kind of a non-relational database type structure. And so we went through a very large user research study to try and figure out what would it look like for us to have, I call it row-level access for people who don't know anything about FHIR kind of in our internal implementation, but really resource-level access controls. And I think, I'll talk a little bit about how this differentiates between some of the other access controls. Thank you all for joining me. I know that there's another access control talk happening right now, so I'll talk a lot about kind of this versus SMART versus some of the other, ways that you can control access to the database. So basically, when we did the research study, there was two main user personas that came out. There was the patient, I want to share my data, but then there was also the administrator. So the administrator is one that says, I don't want to share mental health data with practitioners other than psychiatrists. Now that kind of model of filtering data by a user persona is a little bit interesting because it's not something that we can just scope to a patient compartment. The other thing that got brought up was, even in a patient compartment, if we say, yes, you have access to my patient data. Well, if you live in the United States like I do, probably people are aware there's some unique laws and legislation right now that's happening around female reproductive rights. And so you might say, I want to scope my data based on the fact, it's about reproductive or women's health data versus sharing it with all my practitioners. And so getting down to that level of granularity where you might actually be filtering on a certain criteria or a certain field is really difficult to do in FHIR right now. There are some experimental features in SMART that are being looked at, but I'll talk a little bit about how we did it versus how some of the other implementations are handling it, et cetera. This also kind of talks a lot about how we can do administrative policies. And so the problem that we kind of came up with is, how do we actually have a patient that has multiple different policies for multiple different scopes? So I'm a patient and I want to share my data. We often call this scope as who, for what, and where. So the who is accessing it, for what reason, and where are they accessing it, or what environment. I could be a patient who is sharing my data for treatment, and the practitioner is in network, but I don't want to allow practitioners who are accessing remotely. That kind of level of granularity is basically how you would normally do this for my other customers in a SQL environment, is actually build this into the search logic, where you say, filter out or return results that are related to specific environments, specific actors. But in this particular case, this is often being encoded in the access policies themselves. So how they're accessing your system, what the token actually looks like that's being passed to us. And so we had a little bit of a unique challenge where we had to take the external information we are receiving and actually figure out how to encode it into our own environment and how to build this in a way that makes sure that we, when returning search values, are honoring the scope and the access controls that are being given to us. And so we kind of went through a lot of iterations of what this could look like. One of the ways, and sometimes this is being handled, is if the information is actually stored in the consent resource, which is how we do it. Some models right now will read consent and then make a decision on how to return the data based on what the response is. So very similar to conditional operations, where it says, if there's an allow policy, then allow this traffic. But one of the issues that you have with doing it that way is often there's, depending on the server, depending on the implementations, there can be indexing delays. So if you're searching a consent resource to figure out if this is an allow or deny policy based on patient information, practitioner information, you might actually be getting a dirty read, because you'll have, if that resource got updated and the patient said, no, I don't want to, I don't actually want to give my consent to share my data, but it hasn't updated in the index. Data that's kind of being, in an asynchronous manner handled at the same time might actually return data that shouldn't be returned, or vice versa. So we wanted to make sure that whatever we did was synchronous with any of the updates that are happening. And we also needed to make sure that it was handled the way that was beyond access tokens. This is a kind of a slightly larger problem than the asynchronous indexing, depending on the server. But access tokens also have, an expiration that they can be used up until the token actually expires. And so, a bad actor could actually have a token. This is the smart implementation problem, where you might actually have a token that would not be allowed or not be could be denied based on a change in the consent policy. But since that access token has not expired, that consent, that person is still allowed access to the data. And so we're kind of thinking about, how can we do this synchronously? How can we do it as fast as possible and at a granular level? And we needed to make sure that we were doing this at scale. So the biggest thing that users said during our research was, don't touch my performance. Do this all. Make sure you're still returning everything as fast as possible. Yeah, because you're Google, you can figure it out. So we did. But that's kind of the biggest thing, is a lot of, and we talked about this morning, whenever you're doing performance checks or profile checks and all these things, any more validation you add into the process actually inherently is going to impact your performance. And so it's extremely difficult. We had to think a lot about how to do this in a way that isn't noticeable externally, and so that we can still be serving the production traffic in a safe way. And so for those who aren't familiar, real 101 on consent, we actually just took the consent scopes of the who, the what, and the where. They're basically encoded into the actor is the who, the purpose is the what, and the environment is the where. And so we take that and put it into the accessor scopes. And that's actually who's doing this and who's accessing it. You could have multiple different scopes associated with the consent. So you could have, you can even say select star, I allow practitioners from any environment to be able to access this. The one thing that's kind of unique for how we did this is, since we're doing granular, we also can do it at kind of the metadata level. So what we actually did is we take consents and we basically aggregate them and create what's called an enforcement object. The best way to describe this, without getting into the super detail, although my eng is in the room, so if folks have questions, we can dive into it. But essentially, we treat consent almost like a configure search. So we actually re-index our database based on the consents. And we do that so that we can do the synchronous serving of this. So it's actually part of our search. Part of our search index also accounts for consents. And so we can handle it with the same level of performance that a FHIR search query would be able to. Really, the way that it's being handled is internally, we're slightly changing the query. So rather than running just a straight search query, we have kind of, think, filtering type criteria between it. And so we're able to do this all at the time of the request and with the same performance that a regular search query does because it's built in. And so I think, talking all about like, how tokens happens or how the token issue, as well as how if you're doing this asynchronously with the read and conditional logic, this was really a great solution for us because it allows us to do kind of all of the things that I had mentioned, that our users wanted, which is performance, which is synchronous capabilities, and doing this really at scale. We do have kind of granular access. You can do source, tag, security, compartment, cascading, individual resources. It does get down to the granular kind of row-level access that we are being asked of. And so technically speaking, this actually uses the same architecture as the Smart on FHIR, where you have your authentication system, you have your token actually has kind of multiple different layers. You can see here, this particular one is, you can be a practitioner, a group, et cetera. You send all of this as part of the header, or it's a consent header that has an access token. We actually built it into our Smart on FHIR proxy, so whether you're sending us a smart token or a consent header, we can handle both of those from the same proxy. And I go into detail, so I'll talk about the next step in a second. But what it actually looks like under the hood is we first do a system level check. So that's just, you have your identity and access management tokens. Can you actually access this server? Or that's a generic check. Yes, this person has access to read the server. And then we go through, and depending on if it's a search query or a CRUD operation, we actually, since that's a binary operation, like yes, this can happen or no, that can't happen, we first actually fetch the data and then validate whether or not we should commit the data, so to say. But a search is the probably more popular one that happens that's really kind of actually changing the way that this data is being returned. So based on the tags are the feature level attributes. So, security tag, for example, and the consent that has been encoded and the accessor scope. So does this accessor scope have consent to access this data? And oftentimes, we kind of treat it as an allow or deny. And depending on the data, that could actually just look like filtering, where you don't know you got 100 resources and only 5 were returned to you, and you might not know the other 100 exist because we kind of were handling this at the search query level. And so what this ends up looking like is there's pretty UI, we're building all these things. But one of the things, and this is an interesting takeaway, as I started this conversation, I said a lot of this started through user research. And so we brought this to, we said, hey, we think we built a solution for row-level access controls and for granular access controls on FHIR that meets all your criteria. It's granular, it's fast, it's performant. And they said, okay, great, but the people that are actually building these resources have no idea what FHIR is. And so we created this user journey of what is actually building administrative policies or even kind of access policies look like. The first step in it is you go figure out what policies you want. Those people are often data stewards and often not familiar with FHIR. And so what we found is the people that were kind of building your security policies, like I don't want anyone other than psychiatrists to access mental health data. They have no idea what that means to put in a FHIR consent resource. So we had these natural language policies that were being handed off to a FHIR expert to be encoded. So every time you see a little FHIR thing, that's imagine someone who knows what they're talking about. Someone in this room probably. That gets encoded. And the second thing they said is, okay, even when I encode that in FHIR, I don't want that applied to my production database until I validate the heck out of that. I want to make sure that it's encoded properly. I want to know how it's going to change my current production environment. I want to know what data is going to be accessed versus denied. And we need to make sure that if we turn this on, worst case scenario, we just started denying all traffic on accident because someone wrote a bad policy. And so it wasn't enough for us to just change a consent resource. We actually had to think through, what does drafting policies look like? What does testing policies look like? How do I actually demonstrate to someone who doesn't know FHIR that the access policies I'm about to enforce actually will be valid for what, the natural language policies that they provided. And that was the hardest for us, because in the ivory tower world that we like to be in, the standards, it's, well, if the consent resource says allow, then you should start allowing. And what they said is, I don't care if it says allow, don't start allowing until we've validated the heck out of that, talked to every administrator, and my CISO signed off on it, then you can start allowing. And that's a really, for us, a very difficult behavior, because we have to start kind of now helping our users to be able to say, okay, draft a policy, and here's unique operations to actually go and start enforcing on that. And so we had to think through this this kind of criteria for a while. Basically what it looks like is, I want to know when someone wants to make a change, what it's doing to the change, what it's breaking, what it's actually over-granting permissions to, and basically that they want to make sure that any of the policy changes that are happening are actually doing what they're supposed to be doing, and not under provisioning any of the information. And so what we rolled out, and this is a little bit unique and not something that is a FHIR-defined operation, but it's something I kind of am bringing up because it's, when thinking through access policies, these are the things we should also think about. We have now two unique operations, one called explain data access. It's, if I give you a resource ID, tell me all of the accessor scopes that are enforced on top of that resource. So you could imagine if an auditor gets called and says, I just got a deny policy from your API, what the heck? The person that doesn't know anything about FHIR can send in well, this was the resource ID. And they say, well, here was your scope. You actually were denied based on the patient consent, based on organizational policies, what have you. So explain data access was really important for kind of our auditing and a lot of that workflow that happened, as well as we have a preview. This doesn't exist yet, but we're rolling it out. We have a preview policies, which is based on these new policies that I have not started enforcing. What is the difference between them and the policies that currently exist in my production environment? So we know what policies you're currently enforcing on. You say, here's the list, 100 resource IDs of consent. Tell me all the differences between those. A lot of the time, it just looks like overlapping policies where you already had an star allow per practitioner or treatment, but sometimes it can be conflicting. It says, well, this administrator was an allow, this administrator was a deny. We always enforce on the deny just because we don't want to end up in the news. But that kind of can be configurable where maybe one was an accident, or that's not the behavior that it's intended to be, and they need to go solve that. And so rolling this out is a lot more graceful, because we kind of are starting to introduce these validation operations that make it so, well, if you do change the data, we'll make sure that you have multiple steps in the process to do checks behind actually how the data is being enforced and how it's going about. And so that's pretty much all. Happy to take questions. I know I went fast, I gave you the heads up. Happy to take questions or release everybody to happy hour and ask everybody for.
I have like 20 questions.
Let's start with one.
I will only do one. I love the idea, and I was thinking, does this apply also to references? Because suppose I'm crazy, mental health, and you forbid the fact of condition being crazy, and you will not show that to any other provider which is not mental health.
Yep.
But suppose that my provider...
Is this a personal antidote? Because
yes,
I don't know
always,
if HIPAA applies.
Always,
right, okay.
Always. Suppose that I'm on this medication because of that condition. Mm-hmm. We should also not show the medication? That's my question.
Yeah. No, so we introduced something called cascading, very similar to InSmart, how they have the patient compartment. You can say patient compartment or encounter compartment, and anything that's referenced with, I want to enforce this policy on those compartments. Anything that's, I believe, in or out, included or reverse included for the compartment, although I'm sure my engineer can correct me, will be enforced for that policy as well. So we call it cascading because we're engineers and our marketing team didn't ask us questions. But we can handle references as long as they're part of a compartment.
Maybe related. So when you're adding data to the server, you would have to, I think, label it somehow that this is mental health data, this is HIV status or something if it's sensitive. Is that a rule-based process, or is that a kind of up to the tool that's adding it?
Yeah, so it depends on what the policy was encoded with. If you have, say, just resource level, so anytime data is written, since we changed our index, it automatically is enforced. The second, the second it's written and indexed, that index includes enforcement. If the encoding was, say, patient resources, it doesn't need to be tagged. If the policy has meta tag, meta.security, or meta.source, and you were enforcing on things from that particular source, the data would have to have that as part of when the data is written. It has to be included in that resource, which I think is actually, this is a good shout out for all the security working groups. Right now in the wild, we see very little data coming to us with with security tags. And then we tell people to go tag their data and they tell us no. And it's a very difficult process to go through, and augmenting FHIR data in place is not an easy process. And so that's kind of actually why cascading came out, is they said, I don't want to go tag it. I want you to go cascade the policy without it. But ideally, especially when you think about kind of HTI2 and the fact that patients are going to have opt-out, I suspect we'll start to see a lot more of those kind of security level tags in the wild, which will hopefully make this process a little bit easier. Most of our customers are relying on the compartment definitions, not tags, because if they're receiving data from other servers, it's risky to define a policy right now with a security tag and get data without a security tag, and the patients might not want you to return that data, but if other servers are not up to the same snuff that you're kind of enforcing it with, it's too Wild West right now for relying on that.
I have more questions, but I
Yeah, the gentleman here.
Thank you. Great topic. I think great solution as well. I have two-part question. The first question is the actual consent, where the data is coming from, the source of the consent. The additional question to that is that, can we use the data coming from EHR to say a patient consent for research in EHR, can we utilize that to enforce the same thing? And the second question is, if this is, if you look from the perspective right now, is from maybe from provider or patient who's accessing this data. So looking at from a third-party perspective to say, if we want to share this information from outside to like payers for value-based care, can we utilize that population kind of thing with the same kind of information? Because ultimately, we want to utilize the same filters. So say, I have 50,000 patients as part of this population, and only this person can only access these 50,000 patients, nothing else.
Yeah, so my recording voice put back on. So yes, on the second, so an accessor scope can be a group resource. So we know anyone within that group, often we see that with payer systems, or it could be for a purpose of billing, et cetera. And then a select star for the users. The scopes are somewhat overlapping with SMART scopes. They just are more granular in the amount of them we can do, as well as not just beheld to kind of search. I think I actually have look at that. Not just beheld to search traffic. And so that's a little bit different, kind of the multi-request scope layering that you had talked about, so that you can have, is it payer for billing purposes, et cetera. Your first question on...
Was about the patient consenting for research in the EHR can be utilized.
Yes, so the consent resource has to exist in our database, and you have to tell us to start enforcing on it. So it can't be in the draft phase that I had mentioned, because that means it's still being validated. Where that consent resource comes from, we don't take an opinion on. A lot of the time we get patient EMRs are sending patient consent resources right now. So those will come from the EMR, and we'll know to start enforcing all those. Admin consents are often, those are the ones where there's a lot more time spent in the validation phase, because those tend to be the ones that affect the entire database, not just that patient. And so those tend to be coming basically from database administrators. But who wrote the resource is less important than you told us to enforce on the resource. And that is kind of the policy that you need to run enforcement of access controls is like the highest, hardest, basically database owner kind of level action. So you can't just write a consent policy and it will start happening, and because that was exactly what they told us they did not want to happen. Also, I'll deny.
Great talk. Thank you. How do you see this? Obviously, this solution works very well, probably for a Google product, right? Do you see this solution going outside to maybe other products, or to be like maybe a standard, or how does would it even go outside the FHIR world, or how does it compare with something like Open Policy Agent or other kind of rules, like Zanzibar rules? Or
yeah, so since we use the consent resource, I mean, a lot of this is advocating for better use of that resource, and also better use of things like security tags, because right now, no matter even how it's being enforced, a lot of servers that are looking at consent enforcement do rely on things like it being encoded in consent or it having a security tag. And so regardless of the actual implementation, it is beneficial for the community to get behind using consent and using security, a lot of the security working group aspects. And so just because we did it this way, a lot of Happy does it a different way. They had an awesome talk on it last year. There was an interesting talk this morning with CDS hooks. As long as the consent resource itself is interoperable, the server-specific aspects, I think it really just depends on what you're using it for. Now, outside of FHIR is an interesting question. This is actually what we called consent v2, because our consent v1 was a generic product that was meant to be overarching over, whatever, DICOM, FHIR, all that data. And then everyone was like, just do one thing well, don't do everything else terribly. And so we actually re-upgraded to a FHIR-based consent. And so Having had that experience, I will say it's not very applicable, but I'm sure someone smarter than me will figure out how to make it work. But for it to kind of expand beyond a FHIR server, the nuances are kind of lost in the implementation, because we tried, and it was.
Anyone else? I was skipping Diego.
I have encountered some use cases where I needed to limit who can write, not access, but creation and updating.
Yeah, so that's, so I was told this morning that right now it's just read, but we can do writes. We would do it through the second piece, and this is actually how we do reads today, but I can add it as a feature request for us to do writes. I'm like, I stood up on stage and said we're gonna do it, so now I have to do it. So basically, actually, it's slightly different than search since there's no index associated with any of the CRUD operations. And so we actually will take the operation, and at the same time as we are doing that operation, compare the consent enforcement. Since we can do both those reads synchronously and not touch index, we actually can basically, you'll see, it may actually just roll back a write. So we may write it and then realize we weren't supposed to and write it back before actually returning a valid 200 OK request to the user. We do this on reads, but writes weren't implemented yet, which is a benefit of Smart on FHIR until I fix that, and then we're back.
One last question. You talked about audit a little bit. Can you talk about whether can I see who is accessing my record later in time?
Yeah, yes. Depending on, for us you can, but that's a server implementation. Yeah. In general, since it's happening through an access token, all of that should be being logged regardless. Now what's interesting is, what did that data look like at the time of read? That's kind of a different auditing problem that we're kind of encountering now, which is actually I want to know what did that person see a year ago, not just what data that they could see now. Lots of versioning problems in that one, but yes, technically speaking, there's a audit trail of who was accessing, who was rejected access, things like that. And any kind of API, good API monitoring and proxy system will allow for that, regardless of our implementation.
No one else? Still?
You mentioned that you have a kind of overall search index, so that must have all the search parameters possible, including the consent ones. Do you have a visual or picture of that somewhere?
I'm just like imagining chaos. I don't think so. So some of the search parameters are built in by default. We also allow custom search parameters. So if a user sends us a search parameter and then says, configure search, we will actually go and re-index our search index. Essentially, that's what's happening here too. Like, we're treating the consent almost as like, go re-index your database based on these enforcement policies. There's kind of, I think I probably have a picture somewhere I can find after. I'll find you after. But the back end also has, for like binary and objects and stuff, there's also an object storage. And so the index is chaotic because there's synchronous indexes, there's asynchronous indexes, and then there's new search indexes, and then there's consent indexes. And all of those at any given time are constantly kind of reshuffling based on what operation is being run at the time.
So another question.
So I'm curious about the indexing time. If I understood correctly, you said when the consent changes, you're actually re-indexing the database.
No, so that was, go ahead, finish your question.
Sorry, help me understand, like what are the conditions on which the re-indexing happens?
Yeah, so when the consent changes, that was actually what our users responded, that they do not want us to immediately start enforcing. Because if someone a bad actor writes a new consent, or if someone updates a consent and they haven't validated that they actually want that enforcement policy to go to production. So if someone just writes a deny all traffic, they could shut down your FHIR server if we started, if we immediately started enforcing. And so all of our users said, in production, you can't just change access policies, especially when there's the Wild West of resources coming to us. We need to make sure that when it's being enforced, it is a conscious decision by our security team to do so. This is largely for administrative policies. It's slightly different for patient. You can turn on, if there's new patient policies, to automatically do it. But for administrative policies, it was very clear that they said, we need to tell you when to start enforcing that. And that's actually when we'll kick off the reindexing of the database. And then once that's kicked off, any new data that's being written will basically automatically be included in the new enforcement policies.
Well, thank you very much, Vivian, for such a nice talk and good questions and answers as well. So, yeah, everyone wants to go for a drink. So first, thank you, Vivian, very